Hokie dokie. In this problem, we are given the function g of x, and the goal is to identify the g values of the local max and local minimums. The procedure in this case will be to find the first derivative, set it equal to 0, and factor in order to find the x values that make g prime equal to 0. The exact same process we used in the very first problem in the learning path where they asked for critical points. That's exactly what we want to do. We want to find the critical points. Once we have the critical points, the two x values, we will plug them directly into the original function. And depending on what the g values are or the y values are, whichever is the higher of the two will be the local max. Whichever is the lower or the lesser value will be the minimum. All right, let's do it. G prime, the derivative is 6x squared plus 12x minus 48. And we set this derivative equal to 0. I want to say in this problem, you should always be able to factor out a 6 as a greatest common factor. I want to say that'll always work out this way. So keep that in mind when factoring. So we should have 6 times x squared plus 2x minus 8. So then it's the x squared plus 2x minus 8 that we want to factor. Two numbers multiplying to negative 8, but adding to 2. Plus 4 and minus 2. Setting x plus 4 equal to 0, and solving for x, we get negative 4. Setting x minus 2 equal to 0, and solving for x, we get x equals 2. These are our two x values. Now, we don't need to do a number line or anything for this one. Kind of a shortcut method is just to plug in these x values to the original g function. So that's what we're going to do. Whoops. All right, let's try that again. All right. So we are plugging in negative 4 into this original function. So 2 times negative 4 cubed plus 6 4 squared. 6 times 4 squared. Minus 48 times 4. Oh, shoot. I'm sorry. That should be negative. So for the squared, it really shouldn't matter. But I'll just make it more complicated on myself here. Here we go. Okay. Negative 4 times 48, and then plus 2. All right. So we get 162. So likely that will be our maximum. Now we want to plug in positive 2. So I may just replace what we have going on here. Throwing in 2 wherever we had negative 4. And this will give us negative 54. So we had 162 and negative 54. The higher value becomes our max and the lower is our min. And we find the answer that has both values. And in this case, when we break out the eraser, we see that A is that answer. All right. Let's go and do one more real quick. Oh, this looks fun. There's no x squared term. Okay. So maybe it's a little different. Using the same process, though, we have, we first want to find the derivative. So 2 times 3 is 6x squared minus 54. And that's it in this case in terms of the derivative. So we want to set this equal to 0 and factor. If we factor a 6, again, out of both terms, we'll have x squared minus 9. Difference of 2 squares here, x squared and 9, can still be factored. I'm going to just leave off the 6, kind of like I did with the last one. Difference of two squares is the situation where we have plus and minus. And so x plus 3, x minus 3, since 3 is the square root of 9. Another way to think about it is we need two numbers that multiply to negative 9 but add to 0. That's pretty fun, right? So x plus 3, x minus 3. All right. Each factor will give us negative 3 and positive 3, respectively. And these are the values we want to plug in to g, the original function. Starting with negative 3. We get 104. Now, just replacing, or I was about to say replacing the negative 3's with 3's, or just eliminating the negatives, we get negative 112. All right, 104 is the higher value. That is our max. The lower value becomes our minimum. 104 and negative 112 looks like option D. And we break out the eraser to see that D is our answer. If you have any questions on the process for this one, please let me know.